Want to ace the TOGAF 9.2 exam and boost your career? In this video, we will break down everything you need step by step, making complex concepts simple. Let's get started. Our learning goals are simple. I want to help you prepare for review and pass the TOGAF 10 Part 1 examination with as much confidence as possible. The course that we have designed has been fully aligned to the approved Open Group certification and study guide for version 10. The goal of being able to pass this kind of exam is to demonstrate very clearly to employers and peers your commitment and knowledge of enterprise architecture as a discipline. So why TOGAF? Well, it is an open method for enterprise architecture. This means it helps avoid lock-in to proprietary methods that only some people know and only some people can follow. It brings standard and best practice tools and techniques to the way you design, build, and execute on all your projects. And it has a knowledge-based certification program. This means that it can prove to both payers and employers that you have the skill necessary to take the next big job. So how did TOGAF become the standard? Well, it was a community-driven and collaborative approach. It focused on what matters the most in lowering the overall risks in the difficult-to-plan phase. When you are using the TOGAF framework, it helps you respond to the need of the business while considering both the present and the future. Our goal is to explain the information in a simple and easy to understand way. This course covers the following topics: preparation for the TOGAF foundation exam, overview of the structure of the TOGAF standard document, understanding key definition used in the TOGAF standard, basic and core concept of the TOGAF standard, understanding the architecture development method ADM used in the TOGAF standard. We will explain the latest updates. I suggest to quiz yourself and see how well you do. There is a huge list of key deliverables and terms that will show up on your exam. There is also an activity file of key terms deliverables and their definitions that you can import into a tool of your choice. All of the definitions have been compiled directly from the TOGAF standard or the TOGAF version 10 foundation study guide. I can't stress more the importance of the flashcard. It greatly decreases the time spent studying. Recommend the use of Anki or Quizlet, and is a tool that utilizes what is called spaced repetition, a specific algorithm for better retention of when you are trying to learn material. It automatically reviews your quickest card and it tries to help build strings very quickly within your capability. So this video we are going to be talking about the TOGAF 10 certification. The certification consists of two parts. Obtaining a passing score in the Part 1 exam results in being certified with TOGAF Foundation. Passing Part 2 of the TOGAF exam leads to TOGAF Certified Stat. And if you pass any of this certification, you can use the Open Group logo on your CV or website so that people know you have achieved this accomplishment. These are languages that TOGAF exam is available in English, Spanish, Portuguese, Chinese, French. The cost to take the combined exam is $595. Part 1 exam for verification that the candidate has guide knowledge of the terminology and the basic concepts of the TOGAF framework and understanding the core principles of enterprise architecture and TOGAF. Part 1, the exam is an assessment that measures fundamental knowledge of the standard. A test consists of multiple choice questions with only one correct answer. The exam consists of 40 questions and has a duration of 60 minutes. To pass the exam, a minimum score 60% or 24 correct answers out of 40 is required. The cost of the test is $395. You have to wait 1 month before you can retake the exam. Exam number OGEA-101 English. Part 2 exam for validation that in addition to knowledge and comprehension, the candidate is able to analyze and apply knowledge of the TOGAF framework. Part 2, the exam is an assessment of your ability to apply the TOGAF standard. The evaluation involves a test that is based on scenario and utilizes a gradient scoring method. The gradient scoring in gradient means that you are given points for answers that are closer to the correct answer. For example, if there is a question with a correct answer worth 5 points and you choose an answer that is closer to the correct one, you may be given 3 points. This is what is meant by the gradient scoring. An open book examination. An open book exam means that there will be a PDF version that you can refer to during the exam by pressing a button on the screen in front of you, which will open a TOGAF standard PDF. But this doesn't mean that you can bring a book with you to the exam or open any book other than a TOGAF standard PDF. The exam comprises of 8 questions and has a duration of 90 minutes. A minimum score of 60% is required to pass the exam. To take the Part 1 exam, passing the Part 1 exam is required. The cost of the test is $395. You have to wait 1 month before you can retake the exam. Exam number OGEA 102 English. If English is second language, additional time can be provided for people taking an English exam. If English is not their first language, extra time is 30 minutes. The Open Group website offers a free HTML or PDF version of the TOGAF standard, which can be downloaded by creating an account on the TOGAF library. And you must learn how the TOGAF standard was organized and constructed because it is very useful in the Part 2 exam. Therefore, when opening the PDF file, you should know where to look for information, and this will greatly help you pass the exam. I recommend reading the section explained in each video after watching it, and every time we explain concept and terminology after the video, go and read them so you can easily memorize them in minutes. TOGAF 10 standard consists of 6 parts. Introduction and core concepts introduces the TOGAF standard and outline core concepts. ADM Architecture Development Method describes the TOGAF ADM, which is an iterative approach to developing an enterprise architecture. ADM technique contains a collection of techniques available applying the TOGAF approach and the TOGAF ADM. Applying the ADM contains guidelines for adapting the TOGAF ADM to address the specific style of architecture required in a practical context. Architecture content describes the TOGAF content framework and Abstraction Metamodel for architecture artifact and an overview of typical architecture deliverables. Enterprise Architecture Capability and Governance discusses the organization, process, skills, roles, and responsibilities applicable to an enterprise architecture team. The TOGAF standard has been split up into documents. There is the fundamental content which is covered in this course. The TOGAF series guide is still considered important, as you can see. And finally, there is this extended content which is not necessarily critical for everyone. Portfolio of additional guidance material which supports the practical application of the TOGAF standard. It is TOGAF library. So we went through just in this video the fundamental content and those 6 particular documents that are part of the fundamental set and the series guides to address specific concern and use case with further explanation and more detail than core content. What is TOGAF? It's an architecture framework. It provides the method and tools for assistance in the acceptance, production, use, and maintenance of an enterprise architecture. It is based on an iterative process model supported by best practice and a reusable set of existing architecture assets. And we can also say it's a framework for enterprise architecture. It may be used freely by any organization wishing to develop an enterprise architecture for use within that organization. What is architecture? It has 2 definitions. ISO IES IEEE defined it as the fundamental concepts or properties of a system in its environment, embodied in its element relationship, and in the principles of its design and evolution. The TOGAF standard embraces but doesn't strictly adhere to ISO IES IEEE terminology, defining it as the structure of components, their interrelationship, and the principles and the guidelines governing their design and evolution over time. Using TOGAF with other frameworks. There are 2 primary goals to a framework. The first is that it should define deliverables that an activity should produce, and the second is it should describe a method for the production. Since TOGAF is framework agnostic, you can tailor it. This really helps fill in the gap and provide the how when using a framework with detailed deliverables. So what is an enterprise? Well, an enterprise is a business or company with the goal of making a profit. Sometimes it is very large. It is a collection of organizations that share a common goal. And an extended enterprise can actually include things like vendors, suppliers, customers, or partners. Let's explain it once again in a fresh manner. An enterprise is any collection of organizations that has a common set of goals or process or operating model or structure or scale. And an enterprise could be a government agency, a whole corporation, a division of a corporation, a single department, a chain of geographically distant organizations linked together by common ownership. What is enterprise architecture? Enterprise architecture, on the other hand, is the practice and collection of skills that is used to align technology strategy with the specific business strategy. It is about deliberately making decisions on the way components are organized, people and process are supported, and the evolution of the company is managed. Primarily, being a good enterprise architect means you are doing a lot of listening before necessarily jumping into planning, integration, and big picture thing. Your goal is to help executives and managers make tech decisions that are aligned. Let's explain it once again in a fresh manner. Enterprise architecture is the process of translating business vision and strategy into effective enterprise change by creating, communicating, and improving the key principles and models that describe the enterprise future state and enable its evolution. Or we could say a conceptual blueprint that defines the structure and operating of an organization. The intent of an enterprise architecture is to determine how an organization can most effectively achieve its current and future objectives. Let's explain it once again in a fresh manner. Description of an enterprise as a system in terms of its components. There is interrelationship principles and guidelines governing the design and its evolution, usually done to identify gap between current state, desired future state. Provides roadmap for organization to achieve its goals, deliver its objective, often described at multiple levels of rates and depth. Enterprise architecture is the structure that can help. At its most effective, enterprise architecture enables effective execution of an organization strategy to achieve change. Business architecture is a major enable component of an enterprise architecture. Its architecture is a major enable component of an enterprise architecture. Why do I need it? Well, without enterprise architecture, we are missing the glue that brings together multiple parts of an organization and its process. Enterprise architecture also helps the organization respond to change market needs and support the delivery of the business strategy it's chosen. It helps give guidance on how to take existing proposals and even future vision and make them work together. Let's explain it once again in a fresh manner. Because it is effective management and exploitation of information is key to business success and competitive advantage. A good enterprise architecture optimizes the fragmented legacy of process, manual and automated to an integrated environment, responds to change, supports delivery of the business strategy, enables the right balance between IT efficiency and business innovation. What specifically would prompt the development of an enterprise architecture? Preparation for business transformation or radical infrastructure changes initiate an enterprise architecture review or development. Key people identify areas of change required for new business goals to be met. These stakeholders have areas of interest known as concerns that need to be addressed. The architect identifies and relevant stakeholders' requirements, develops views of the architecture that address those concerns, shows trade-offs that are necessary between conflicting concerns. Without the enterprise architecture, it is unlikely that all the concerns and requirements will be considered and met. Business benefits from a good enterprise architecture. A more efficient business operation example, lower business operation costs, more agile organization, business capabilities shared across the organization, lower change management costs, more flexible workforce, improve business productivity, better return on existing investment, reduce the risk for future investment example, reduce complexity in business and IT infrastructure, maximum return on investment in existing business and IT infrastructure, the flexibility to make, buy, or outsource business and IT solutions, reduce overall risk in the new investment and their cost of ownership, a more efficient IT operation example, lower software development support and maintenance costs, increased probability of applications, improve interoperability and either system and network management, improve ability to address critical enterprise-wide issues like security, either upgrade and exchange of system components, faster, simpler, and cheaper procurement example. Buying decisions are simpler because the information governing procurement is readily available in a coherent plan. The procurement process is faster, maximizing procurement speed and flexibility without sacrificing architectural coherence. The ability to procure heterogeneous multi-vendor open system, the ability to secure more economic capabilities. Let's explain it once again in a fresh manner. There are three primary business benefits. I break them down into efficiency, harmony, and simplicity. From an efficiency standpoint, you become less reactive to change and you are better at risk management. You panic less, you have better capabilities, which means a standard of excellence for everyone is higher. It makes it a lot easier to upgrade and exchange components that have been designed on a common architecture and with a goal in mind. And with the reduced cost of ownership that good planning brain, it will give a higher return on any investment for dollars that is spent. On the harmony side, it improves the portability of applications. There is better interoperability of the infrastructure that get installed, and it much easier to work with multi-vendor solutions because they all understand the building blocks that you have created. This reduces complexity for both business and IT. From a simplicity standpoint, it is quite simple. Good planning helps make better decisions. It makes them more structured. It makes them more transparent and it holds the people accountable. It makes it a lot easier to hit the goals that you set out to achieve. What is a framework? It is a structure for content or process that can be used as a tool to structure thinking, ensuring consistency and completeness. Why do I need a framework? You might be asking yourself, why do I need a TOGAF framework or any framework for that matter? Well, TOGAF simplifies development by providing a toolkit. It makes sure that you don't miss anything during plan, build, and run phases. It helps making decisions that can scale with future needs. And sometimes it is required as part of regulatory or government. Key components of framework include it should build a common language and a set of tools that everyone can use and apply in the same way. It is nice to be able to go into a meeting and be able to pick up where someone left off. It is also nice to be able to design in a way that you can grow and scale your designs using things like modular design principles. We can take building blocks and put them together so that small, simplistic ideas can generate grand designs. Typically, a framework should also be able to recommend standards and compliant products so that everyone building in a way that people expect things to be built. What is an architecture framework? An architecture framework is a foundational structure or set of structures which can be used for developing a broad range of different architectures. It should describe a method for designing a target state of the enterprise in terms of a set of building blocks and for showing how the building blocks fit together. It should contain a set of tools and provide a common vocabulary. It should also include a list of recommended standards and compliant products that can be used to implement the building blocks. Let's explain it once again in a fresh manner. Framework a structure for content or process that can be used as a tool to structure thinking, ensure consistency and completeness. Architecture framework, a conceptual structure used to develop, implement, and sustain an architecture, may be used to deliver a broad range of architectures, should contain a method for designing a system in terms of a set of building blocks, a method for showing how the building blocks fit together, a common vocabulary, a content framework. Let's explain it once again in a fresh manner. It's a tool that can be used for developing a broad range of different architectures. It should describe a method for designing an information system in terms of a set of building blocks and for showing how the building blocks fit together. It should contain a set of tools and provide a common vocabulary. It should also include a list of recommended standards and compliant products that can be used to implement the building blocks. We also want to cover the four architecture domain be that. This refers to first the business domain where we talk about things like strategy, governance, and the key process. Followed up with the data domain. This refers to the logical and physical data assets that we have and the management of those assets to make sure that things are not lost at the right level of quality and ready for system to use. The application domain talks more about the interaction and relationship to core business process and how they support strategy. Application is more people oriented and skill oriented rather than IT oriented. The last one, technology, is where the applications and technology exists. It is where we talk about things like software, hardware capabilities required to support the business, middleware, network, communication, process, standard, and all the stuff that an engineer love to discuss. Together, be that business data application technology from the foundation of TOGAF. Let's explain it once again in a fresh manner. Business architecture defines the business strategy, governance, organization, and the key business processes. Data architecture describes the structure of an organization, logical and physical data assets, and the data management resources. Application architecture provides a blueprint for the individual application system to be deployed, their interaction, and their relationship to the core business process of the organization. Technology architecture describes the logical software and hardware capabilities that are required to support the deployment of business data and application service. This includes IT infrastructure, middleware, networks, communications, process standards. Let's explain it once again in a fresh manner. Business architecture includes business strategy, governance, organization, key business process. Data architecture includes structure of logical data assets, structure of physical data assets, data management resources. Application architecture include a blueprint of application, interaction to other applications, relation to business processes. Technology architecture include software and hardware capabilities, IT infrastructure, middleware, network communications, process and standards. Architecture abstraction. So TOGAF divides an architecture effort into four distinct levels. You have the contextual abstraction, the conceptual abstraction, the logical abstraction, and the physical abstraction. The contextual abstraction are the environment of enterprise and the context of architecture work. For example, motivation, drivers, scope, goals, objectives. The conceptual abstraction, also known as surface or behavior abstraction, are all the requirement and surface models. For example, business surface, application surface, technology surface. The logical abstraction level contains all the implementation, independent solution, alternative to achieve surface, for example, business, data, application, and technology component. And the physical abstraction level has all the alternative for allocation into implementation of physical component to meet the logical components for instance principles. The abstraction levels of TOGAF cross the architecture domain. It is a learning concept moving from high-level models to more detailed models. So the architecture abstraction levels help you in posing structured question about an architecture. So the why is the architecture needed? The what functionality and other requirement need to be met by the architecture? The how question, how do we structure the functionality? And the question, with what asset shall we implement this structure? Dividing a problem area into similar problem areas are either to model and to solve. The content framework defines a categorization framework to be used to describe the building blocks and artifact reflecting decisions taken in creation the overall architecture deliverables. The content framework is intended to provide a detailed model of architecture work products, drive consistency in the output create when following the ADM, provide a comprehensive checklist of architecture outputs that could be created, reduce the risk of gaps within the final architecture deliverable set, help an enterprise mandate standard architecture concepts, terms, and deliverables. Let's explain it once again in a fresh manner. The architecture content framework, also known as content framework, is a categorization framework to describe the building blocks and artifacts. The framework is starting point for enterprise architecture by structuring architectural information. It contains the minimum required enterprise architecture information to address the most pressing and recurring questions. It mirrors the phases of the architecture development method on its top-level structure. Architecture content framework is influenced by use enterprise architecture framework and software tooling and is also known as content Metamodel. It is developed by using an established meta model or by deriving the required entities and relation of the open question within the EDM preliminary phase. The content framework is adapted to fit specific needs of the organization. It is a detailed model of architecture work product. It ensures consistency in the outputs when following the architecture development method, the ADM. It is also a comprehensive checklist of architecture output that can be created. It reduces the risk of gaps within the final architecture deliverable set. And the content framework mandates standard architecture concepts, terms, and deliverables. The architecture content framework is part of the enterprise-specific architecture framework. It contains of several parts: architecture principles, vision, motivation, and requirements. Purpose capture the surrounding context of formal architecture models include general architecture principles, strategic context that forms input for architecture modeling, and requirements generated from the architecture. Focus investigate relevant aspects of the business context that have given rise to the request for architecture work are typically investigated, refined, validated, and recorded in the preliminary and architecture vision phase. Business architecture purpose capture architecture models of the business focus on factors motivating the enterprise, its structure and capabilities. Information system architecture purpose capture architecture models of IT systems focus on application and the data aligned with TOGAF ADM phases. Technology architecture purpose capture technology assets use focus on implement information system solutions. Architecture realization purpose capture change roadmap debug transition between architecture states and binding statement. Focus for steering and governing architecture implementation. Architecture change management purpose capture value realization management events internal and external that impact the enterprise architecture. Focus on the generation of requirements for action. Enterprise Metamodel. The Enterprise Metamodel outlines the type of entities featured in models describing the enterprise along with their relationship. Example in Enterprise Metamodel role could be a type business architecture models may then include instance of this role type such as tailor, pilot, manager, volunteer, customer, or firefighter. Although it is uncommon for an enterprise to have all these roles simultaneously, an enterprise meta-model provides value in several ways. It gives architects a start set of the type of thing to investigate and cover in their models. It provides a form of completeness check for any architecture model, language, or architecture meta model that is proposed for use in an enterprise. Namely, how completely does it handle the type of entity in the enterprise meta model and manage required facts about them such as their attributes and relationships. It can help ensure consistency, completeness, traceability developing the enterprise meta model. So the enterprise meta model is part of the organization specific architecture framework of the enterprise continuum. Developing a high quality meta model is an important aspect of established the enterprise architecture capability. The type of entity within an enterprise and the relationship between them are specific to the individual enterprise. The TOGAF standard doesn't aim to concern an enterprise selection of artifact modeling notation, for example, the Archimate modeling language, business process modeling notation TM, Unified modeling language TM, entity relationship diagramming, flowcharting, or any other notation that can express some TOGAF ideas. The TOGAF standard comes with a foundation level called Enterprise Meta Model that supports the architectural work. It is about a list of common entities and relations that are likely to be required in modeling most enterprise. The foundation level core enterprise meta model gives you context for the artifact and suggested in the architecture development method. It is a structure of architectural information which meets stakeholder needs. When you complete a phase in the architecture development method or ADM, there are a lot of different types of outputs that you can create. These outputs are categorized as either deliverables, artifacts, or building blocks. Deliverables. A deliverable is a work product that is contractually specified and in turn formally reviewed, agreed, and signed off by the stakeholders. Deliverables represent the output of project, and those deliverables that are in documentation form will typically be achieved a compilation of a project or transition into an architecture repository as a reference model, standard, or snapshot of the architecture landscape at a point in time. We can say a work product that is contractually specified, formally reviewed, agreed, and signed off by stakeholders. Let's explain it once again in a fresh manner. Deliverables represent an overall work product that is agreed to, completed, reviewed, and then signed off on by a stakeholder. Imagine a deliverable as being something you have to produce, you have to finish at the end of the day, something that you promised. Deliverables can be achieved or even transitioned into an architecture repository, also known as a library when completed. Example of deliverables include things like reference model, standards, or snapshot. There are a lot of deliverables and key terminology that you are going to be tested on throughout the exam. Deliverables are items that are produced and used across the entire ADM lifecycle. It provides a baseline of architecture in order to better define the activities required when you are going through each of the phases in what they call is the ADM. It acts as a starting point for a lot of our customization. Artifact. An artifact is a more granular architecture work product that describe an architecture from a specific viewpoint. Example include a network diagram, a server specification, a use case specification, a list of architecture requirements, and a business interaction matrix. Artifacts are generally classified as catalogs, list of things, matrices showing relationship between things, and diagrams, picture of things. An architecture deliverable may contain many artifacts, and artifacts will form the content of the architecture repository. We can say architecture or product that describes an aspect of the architecture. Let's explain it once again in a fresh manner. An artifact is a detailed work product describe an aspect of the architecture. Architectures help form the content of the architecture repository or library. Examples of artifacts include things like network diagrams, machine specification, or use cases. Artifacts actually have three different subtypes. The first subtype is known as a catalog, which is basically a list of things. The second type is known as a matrices. It is more of a relationship diagram that show how two different parts may be interrelated. For example, how stakeholders and accountability might be interrelated. The three type is a diagram, and a diagram is basically a picture. For example, a network diagram or a database relationship diagram. Building blocks are reusable components of work that can be combined. There is two major types: architecture building blocks and solution building blocks. Architecture building blocks basically describe requirements. Solution building blocks, on the other hand, describe components or solution required to implement those requirements. So a solution building block may be an actual piece of software, whether an architecture building blocks might be something that describe a need. Building blocks improve in level of detail as you progress through the ADM phases, starting from generic to finally becoming organizationally specific. Building blocks are package of modular functionality with a published interface that conforms to a standard. Building blocks can be used on their own or as a part of a sub-assembly. Building blocks typically evolve to exploit new technology as it becomes available. You can really create some very complex design with a series of simple building blocks. Let's explain it once again in a fresh manner. Represents a potentially reusable component of business IT or architecture capability that can be combined with other building blocks to deliver architecture and solution. Building blocks can be defined at various levels of detail and they can relate to both architecture and solution. A potentially reusable component of business IT or architecture capability. Architecture building blocks. One type of building block is an architecture building block. Architecture building block or ABBs define functionality that will be implemented. They capture business data, application, and technology domain requirements. They direct and guide the development of solution building blocks or SBBS. It also includes a statement of any reference architecture that is being reused. Solution building blocks. Solution building blocks define products and components that will eventually implement the functionality. This is define the implementation, fulfill the business requirements, and are typically product and vendor aware. Let's explain it once again in a fresh manner. Architecture building blocks typically describe required capability and shape the specification of solution building blocks SPBS. For example, a customer service capability may be required within an enterprise supported by many SPBS, such as process data and application software. Describe required capability and shape specification of solutions. Solution building blocks represent components that will be used to implement the required capability. For example, a network is a building block that can be described through complementary artifacts and then put to use to utilize solutions for the enterprise. Represent components that will be used to implement required capability. Components of building block. Let's take a look at some of the differences between the two. An architecture building block discuss fundamental functionality and attributes. Whether a solution building block has a specific functionality and attribute. An architecture building block has a chosen set and supply interface. The solution building block deals with the implemented set of attributes. The architecture building blocks and solution building blocks, when they are used, discuss their interoperability to other architecture building blocks or other solution building blocks. They also do this for any dependency. Architecture building blocks have to reference any dependency that they have, and solution building blocks have to do the same. Both should map to organizational entities and policies. The architecture development method EDM is a visual set of phases, each with its own input, step, and output. An output can include a process flow, project plan, set of requirements, or other work artifacts. Outputs should be versioned, agreed to, and then signed off. Each phase and its step can be fully tailored to your organization. Or we can say the core of the TOGAF framework, a step-by-step approach to develop and use an enterprise architecture. Or we can say the architecture development method forms the core of TOGAF and is a method for deriving organization-specific enterprise architecture. It is the result of contribution from many architecture practitioners. Preliminary. Here is what the EDM looks like. We start with the preliminary phase. What this is the preparation and initiation activities required to kick off the EDM and build a capability. Some of our goals include determine the target architecture capability and establish the architecture capability. The way we do this is we start with defining the enterprise scope, including figure out who our stakeholders are and those who will benefit from us doing the work. We have to find a sponsor or a flag carrier, someone who's going to help us when we are in trouble. We then define and baseline the business, cultural, organizational, strategic, and financial requirements of the work. We then define the architecture principles that will guide and inform our work. This helps us create the architecture phase. The architecture vision is where we create an approved statement of work that defines what's both in and out of scope, identifies stakeholders, creates a vision, and defines a specific business goal. Our major objective is to make sure that we get endorsement from a corporate management, confirm support of the line managers, and develop a vision of the capabilities and business value that we are looking to deliver. We have to get an approval for a statement of work so that we can make our vision come true. The beginning of this process starts with a request for work. We then research, verify, and start to gain buy-in to the key business objectives and process that we are looking to support with this work. We use business scenarios to identify and articulate what is it exactly that need to be done and what do those requirements look like. Using those some business models, we show exactly how we are going to create value in the organization through the work that we are doing. We are going to investigate emerging technologies and the impact in how they might be applied and used for the work that we have upcoming. And we describe how new capabilities are going to help us meet our business goals and the overall business and strategic objective. All of this is a bridge so that people can get excited, want to be able to work on this, and specifically want to support the work on this. We start our review with business architecture. The business architecture describes the relationship of businesses, processes, and people. It talks about how each of these groups are impacted by the new architecture and a plan for what we will need to do in order to adapt and change the way we might work once the new architecture is in place. Our major objectives is to develop what we call a target business architecture description, and a candidate for an architecture roadmap. Our overall approach starts with a baseline. This baseline uses pre-existing descriptions if they have existed from previous work. We then apply business capabilities and map them to organizational units, value streams, and plans within the scope of the project. We perform a gap analysis to figure out based on our baseline and our target where are we missing a particular capability, skill, and tool. And we apply the organizational map to figure out who need to be involved, how decisions are going to impact those people, and double check if we have missed anyone from our stakeholder list. During this time, we use a lot of business modeling technique and we use the architecture repository as our library for reference. Information systems architecture is all about describing the changes that need to be made to the data and architecture domains for the new work we are doing. It documents current and target data quality, applications specification, and their interrelationship. Our primary goals is to develop a target data architecture and the target application architecture. We also want to be able to describe how the target architecture will enable the two previous phases of business architecture and architecture vision. The overall approach begins with data management, figuring out where the best source of data is or and defining that system of record, what kind of standards we are all going to adapt, how the data entities will be utilized, where data entities will be stored, the level of iteration, the level of quality, and the cleanliness and the filter, and any transformation steps required. We then look to do some data migration. The level of migration required, the detail on the quality, and again, any cleaning and filtering needed to be able to take our baseline architecture to our target architecture. Data governance considers the structure management of system and people. And we make sure to utilize any relevant industry-specific area of our architecture repository that might have more up-to-date knowledge on how to approach. The technology architecture. It documents our comprehensive technical architecture that describe principles, constraints, and a draft detailed model. Models might include details about systems, protocols, processes, and tools that have been selected during our previous discussions. Our major objective here is to develop target technology architecture and describe how that target architecture will support all the previous phases and build on all the previous work so that we continue going towards our vision and meeting our strategic requirements. The high-level approach is to first of all a gap analysis between baseline and target technology architectures. We then want to look towards our research and utilize some of those emerging technologies we learned about to capitalize on any transformation opportunities. We then utilize the relevant industry-specific and technology-specific areas of the architecture repository if they exist. Opportunities and solutions is where the rubber starts hitting the road. It is describing how the solutions will be implemented, which vendors are going to be selected, which tools the team will utilize, and some sort of migration plan that breaks up all this effort into specific sub-projects and work packages. Our major objectives here is to generate an architecture roadmap. We also want to determine the approach and if we need to have stepping stone or transition architectures along the way so that we can incrementally achieve our final goals. Sometimes build a house is really tough, but if you break it down into the rooms, it makes it all happen a lot easier, and that is what opportunities and solutions are all about. Within this, we also define our solutions building blocks and our architecture building blocks that are going to be used so that we can create our vision. Our high-level approach is to generate a full and complete gap analysis between all any baseline and target architectures that have been developed in the previous phases. We want to build the full roadmap by logically grouping change into work package and the project. We then develop any transition architectures or milestone if we are going to use them. Develop an implementation plan and develop a migration plan. This particular stage set all of your implementation planning up. Migration planning that's the work to get from current to target state by creating a detailed implementation plan. The plan breaks down work into sub-projects and buckets, which are then prioritized. Our major deliverable is a full cost benefit and risk analysis of moving from our baseline to our target architecture so that we make sure that we can tell our key stakeholders why and what we are doing at each phase and what they should expect to get out of it. We ensure that all of our plans are aligned with the enterprise approach to managing and implementing change. During this phase, we also finalize the artifacts, including the architecture roadmap, the implementation plan, and migration plan for final sign-off. Our high-level approach includes meeting with the portfolio and the project member to discuss plans, assess our dependency costs benefits with the projects and the plan. And then finally to integrate this plan with any other change management approaches in place and used by the organization. It is often your project planning team that might know some of these details. Implementation governance. It provides oversight, monitoring, and management during the implementation of the work to make sure it is aligned with the initial goals and vision. We want to be going in the right direction, and implementation governance helps with that. Our major objectives is to make sure that we are conformant with the target architecture. We perform appropriate actions and management based on any implementation driven change request, and those change requests come in often, so we want to make sure we don't deviate from our goal. Our high level approach is to be establish a program that's going to enable the delivery of the agreed transition architecture. We typically want to adapt phased deployment schedule, follow all relevant organizational standards for governance and project management, and define an operation framework to ensure architecture that is implemented is maintained going forward. Architecture change management is all about establishing procedure for managing change to the new installed system so that it continues to provide lasting value to the enterprise. Now that we have built this system, we want to make sure that it keeps giving us the value that we propose. Our major objective is to make sure that the architecture lifecycle is maintained and the governance framework that oversees it is properly executed. The capability should meet current and changing requirements. Otherwise, we might need to do more work. We might need to improve this system that we have. Our high level approach is we monitor the business growth and understand if we are delivering the value that we originally promised from this project. We classify any changes as either simplification changes, incremental changes, or complete architecture change. When we change the existing infrastructure, we use top-down to create capability using the money or capital. If we want it to enhance capability, we typically do it from the bottom up through some sort of operation or maintenance activities or maybe a modification to an existing or ongoing project. Redesigns should usually be considered if there are more than two stakeholders involved. Requirements management is in the center of all of this phase. It is a repository that connects all of these phases together as they get completed. It helps to validate and govern the output of these phases as well as provide templates to complete the step within a phase. It is a great knowledge base and library for all to use, evolve, and pull from. A key objective of the requirements management phase is making sure that it's actually an operation during all phases of the ADM. You are actively using it to bold ideas and reference material from, and you are constantly evolving the reference material and the knowledge that exists within it. We want to manage requirements identified during each phase and readily over requirements reference material so that you can get ideas and use those ideas when you need them. Our high-level approach is to first document business scenarios. Then we want to interface with the library known as the Architecture Requirements Repository. When we are interacting with this component, sometimes we are going to end up utilizing commercial off-the-shelf tools. Now you have a great foundation of the architecture development method. This reliable proven framework will help you develop architecture that meet the business, organizational, and technical needs of an enterprise all without breaking a sweat. The ADM consists of several phases that cycle through domains. Each phase includes steps that utilize assets from the previous iteration and other framework to build strong deliverables. The ADM addresses original requirements and vision through very frequent validation. And when you perform validation, you should reconsider scope, details, schedule, and milestones. There are different iteration types when you are going through the ADM. The first type we will talk about is around where we basically begin with preliminary and go through step A, B, C, D, E, F, G, and H in order. The next type is in between, where I might start with step A, architecture vision, then jump over to step E, opportunities and solutions. Take the information that we discussed there and it is deliverable. Use that to help me perform step B, business architecture, and then maybe update some deliverables from architecture vision before finally continue on to step C, information system architecture. The last iteration type is in play. This iteration type sticks to one particular phase and continuously improves the deliverables that we output. Architecture vision will then go to version 2.0, 3.0, and so on before maybe contain a business architecture and information systems architecture and so on. For each of these iterations, you need to consider what is the breadth of coverage that we will be looking at, how deep and to what level of detail do we need to go. What's the time period that's going to be in scope for this deliverable? And which architecture domains from the BDAT domains will be involved? Finally, which asset can be leveraged from our libraries and repositories? Where does the ADM fit within TOGAF? Well, there are 5 areas the ADM and the TOGAF team to interact. Let's talk about the first. Enterprise Continuum. The Enterprise Continuum helps categorize internal and industry reference material on a scale of very generic to very organizational specific. The relationship to the ATM is we use the Enterprise Continuum during execution whenever you need to make decisions that take generic building blocks and tailor them for your specific need, and when we are interact with stakeholders. The second area is architecture repository. The architecture repository is the implementation of the enterprise continuum. It is the library that holds these materials as a library. It includes reference architecture, models, patterns that have been previously accepted, and any documentation of past work and lesson learned. In terms of its relationship to the ADM phase, often contain reminder to go look in the library and utilize past work, and as you iterate through the ADM, this repository becomes more rich, detailed, and populated because you take things that are generically in the library and you might fit them to your need and then contribute by check them back into the library. foundation architecture is all about an architecture of very generic surface and function that include the technical reference model and the standards information base. The foundation architecture helps populate the technical reference model or TRM and the standard information base or SIB with necessary definition and the customization. It talks about what is in and what is out for scope based on business requirements and the discussions you have had with stakeholders. Supporting guidelines is an extended set of resources, including guidelines, techniques, templates, and checklists. In terms of its relationship to the ADM, it describes how to adapt the ADM process for very specific use in terms of specialty scenarios or specialty architecture. And finally, supporting technique are tools that efficiently achieve a goal or output. When we are talking about the ADM, supporting technique generally helps with specific tasks in the ADM and the ADM phases. There are many reasons that you might want to adapt the ADM. The first reason is order. Sometimes the maturity level of your organization requires that the phases are done in a different order or sequence. Another reason might be integration with other frameworks. Perhaps your organization or industry use a very specific framework and you want to be able to interface with it because that's what other people around you know and use. Sometimes you need to integrate with internal governance. This could be because authorization, risk management, business planning, budgeting, procurement, each of them all have their own way of doing things and change their process is out of scope. You just want to be able to and interface with them in that particular case, and integration may be hard. Brazil is what's referred to when we make a compromise between existing practice and some of the requirements that the enterprise might already have in place. Sometimes you just want to adapt the ADM because it is just too complex. It has too much to handle at once, but there is some great ideas that you can take out of the ADM and start to implement to make better and wrong decisions. And finally, sometimes you want to increase the scalability of the ADM. Maybe the size of your organization is very complex or has multiple enterprise, and there has to be a specific checkpoint tools and techniques that you want to add to the ADM in order to improve the scalability in the organization you are working with. Architecture partition propose you to adapt a partitioning model that reflects the enterprise operating model. You first establish a number of architecture partitions, providing defined boundaries, governance, and ownership. You then apply partitioning to architecture until each architecture has its own entity. And in a certain, each team carry out architecture activity within the enterprise and it owns one or more architecture partitions and will execute the architecture development method to define, gather, and realize their architecture. So why do we do architecture partitioning? Architecture partitioning helps you to simplify the development and the enterprise architecture management. It helps you in conflict management, in parallelization, and reuse on complexity management. So conflict management, there are several organizational unit architectures conflict with one another. Parallelization, the partitions allow for a specific group of architects to own and develop specific elements of the architecture at the same time. Reuse effective architecture reuse requires the modular architecture segment that can be taken and incorporated into product architectures and solutions. And lastly, complexity management. So you organize the enterprise continuum into a set of related solutions and architectures with manageable complexity for each individual architecture or solution. Let's talk about the need for governance. Compliance with the ADM is critical to the governance of the architecture, and that required deliverables are actually being produced as they should be. The architecture board plays an important role in ensure that this method is being applied critically across all phases of the ADM, regardless if you are using the out-of-the-box ADM or you have adapted it. The management of all artifacts should be supported by a controlled environment, such as one or more repositories. There are three major areas of a governance repository. The first is reference data. Reference data details and has description of collateral and reference material, and it is used for guidance and instruction during project implementation. The next is the process status, where I can find the information regarding the state of any governance process, where we are within it, and how well we are doing. And finally, audit information, which records a completed governance list of all the actions that we have done. And it helps us support not only the key decisions like the what, but also who is going to be able to do it and the responsible personnel assigned. Audit information supports future projects by becoming a guide and reference for precedents moving forward. Why would you scope an architecture activity? Well, sometimes we have to fall within the authority of the individual team or department that's asking for the work. We might have to change the scope so that we can meet their particular level of authority and their particular level of influence. Other time, we might want to scope our architectural activity because we want to better meet the objectives and the initial concerns that were laid out by the stakeholders. Sometimes we want to balance the availability of key resources. This can be important when some of those resources might be assigned to multiple projects. In that case, load balance can be achieved by scope your architectural activity. And finally, some work may be very complex or very difficult, and if we change the scope, we can achieve a quicker and more productive win. There are four dimensions that can be used for limiting scope. The first we will talk about is breadth. When we are talking about breadth, we are asking what specific parts of the enterprise should we deal with, which particular organizations or department. The second is depth. What level of detail is truly required for me to successfully hand this off to designers, engineers, and developers? Can I reduce that level of depth to limit our scope, or do I need to have the level that's currently specific? Time period is our third dimension for limiting scope, because we can ask questions like what's defined in terms of activities and planning. And is our time period realistic in order to achieve the vision? Sometimes, instead of a one-shot win, we can look for a stage or transitional approach where we achieve multiple small wins on the way to a goal. The final dimension is in architecture domains. The architecture domains is where we limit the scope in any of our BDAT domains. That's our business, data, application, and technology. The question we will ask here is, do you have time to use all four? Will you use all four? And again, to what specific level in that? When we talk about integration framework, it is all about grouping architectures that help us create a consistent frame of reference. When defining a single architecture, you are already familiar with addressing the full scope of breadth, depth, architecture domain, and time period. If you are looking to integrate frameworks, we must address them using those exact same four boundaries. The Enterprise Continuum. The Enterprise Continuum is a view of the architecture repository that provides methods for classified architecture and solution artifacts as they evolve from generic foundation architectures to organization-specific architectures. We can say the architecture continuum illustrates how architectures are developed and evolve across a continuum ranging from foundation architecture through common system architectures and industry architectures and to an enterprise own organization specific architecture. Or we can say a categorization mechanism useful for classifying architecture and solution artifacts, both internal and external to the architecture repository as they evolve from generic foundation architectures to organization-specific architectures. Let's explain it once again in a fresh manner. Any architecture is context-specific to individual customers, to industries, to subsystems, to products and services. A view of the architecture repository, method for classify architecture and solution artifact, internal and external to the architecture repository, from generic foundation architecture to organization-specific architecture. The Enterprise Continuum provides a consistent language to communicate the difference between architecture. To organize reusable architecture and solution assets. The Enterprise Continuum contains two specializations. The Architecture Continuum, a part of the Enterprise Continuum, a repository of architecture elements with increased detail and specialization. The TOGAF framework identifies the following four types of architecture to indicate the range of different types of architecture that may be developed at different points in the continuum. Foundation architecture, common system architecture, industry architecture, organization architecture. There are not fixed stages in a process. Apply across all architecture domain, business, data, application, and technology. Solution Continuum, a part of the Enterprise Continuum, a repository of reusable solutions for future implementation effort. It contains implementation of the corresponding definition in the Architecture Continuum. Solution represents the detailed specification and construction of the architecture. Solution architectures are populated with reference building blocks purchased or developed for the enterprise architecture. Moving from left to right is focused on building solutions value. Moving from right to left is focused on addressing enterprise needs. Classified assets related to the context of the enterprise architecture. Contextual assets may include policy standards, strategic initiative, organizational standards, enterprise level capabilities. Architecture Continuum provides a consistent way to define and understand the building blocks with generic roles, representation, relationship. This aids traceability and integrity of the architectures. Solution Continuum provides a consistent way to describe and understand the implementation of assets and building blocks as a result of agreement with customers and business partners, communities, and difference between product and system and service. Deploy solution or instance of the solution within a specific context. Foundation architecture. Architectures of generic component interrelationship principles and guidelines which form the basic foundation for the architecture, on and from which more specific architectures and architecture components can be built. The TOGAF ADM is a process that supports specialization of such foundation architectures in order to create organization-specific models. The TOGAF Technical Reference Model (TRM) describes a fundamental architecture upon which more specific architectures can be based. Common Systems Architecture use surface and foundation architecture to create an architecture useful for building common solutions. across a wide number of relevant domains: ERP architecture, security architecture, network architecture, management architecture, operations architecture, integrated information infrastructure reference model, industry architecture, integration of common system components with industry-specific components, retail industry architecture, energetic oil and gas data exchange standards, organization-specific architecture, describe and guide the final deployment of solution components for a particular enterprise, NBE bank architecture, your organization architecture, foundation solutions, desktop product, IT product, common system solutions, management solutions, email security, solutions that can be used to build multiple applications or to a common use such as integration platform, industry solution, telecom-oriented product mediation platform, ERP for telecom, insurance-oriented solution, policy management solution, ERP for insurance, organization-specific solutions, solutions that will only work for your organization. Let's explain it once again in a fresh manner. Foundation architecture, architectures of generic component in relationship, principles, and guidelines which form the basic foundation for the architectures on and from which more specific architectures and architecture component can be built. The TOGAF ADM is a process that supports specialization of such foundation architectures in order to create organization-specific models. The TOGAF Technical Reference Model describes a fundamental architecture upon which more specific architecture can be based. Foundation architecture characteristics reflect generic components of the enterprise architecture included there, interrelationship principles, guidelines, which provide a foundation on which more specific architectures can be built. For example, define technology standard for implementing the enterprise architecture building blocks. Common systems architectures guides the selection and integration of specific services from the foundation architecture to create an architecture useful for building common and reusable solutions across a wide number of relevant domains. Common system architecture. The TOGAF Integrated Information Infrastructure Reference Model is a reference model that supports describing a common systems architecture in the application domain. Common system architecture characters each is incomplete in terms of overall information system functionality, complete in terms of particular problem domains. Example, security architecture, management architecture, network architecture, email architecture. Solutions implementing the common systems architecture can state yet reusable building blocks for the creation of functionality to complete information system. Industry architectures guide integration of common systems components with industry-specific components, guide creation of industry solutions for targeted user problems within a particular industry. For example, telecommunications industry, retail industry, banking industry. Industry architecture characteristics reflect requirements and standards specific to a vertical industry, define building blocks specific to a generic problem domain, contain industry-specific models, logical data models, process models, applications, business rules. An industry-specific example is a model representing the business function and process specific to a particular vertical industry. TMF for telecom industry, energetic data model, accord standard. Organization-specific architectures describe and guide the final deployment of solution component for a particular enterprise and extended network of connected enterprise. Maybe a continuum of organization architectures needs to effectively cover the organization requirement, may result in several more detailed organization architecture for specific entities within the global enterprise. Organization-specific architecture characteristics Provide a means to communicate and manage business operations across all four architecture domains. Define building blocks specific to a particular enterprise. Contain organization-specific business models, data, application, and technologies. Provide a means to encourage implementation of solutions to meet business needs. Provide an evolutionary path to support growth and new business needs. Provides criteria to measure and select products, solutions, services. Foundation solutions, highly generic concepts, tools, products, services, and solution components that are fundamental profiles of capabilities. Services include professional services, training, and consulting service. Ensure maximum investment value from solutions in short time. Support service ensure maximum possible value from solutions. Help desk includes programming language, operating systems, foundational data structure, generic approach to organizational structure, structure for organizing IT operations, common systems solution, implementation of common system architecture. A set of products and services may be certified or branded, represent collections of common requirements and capabilities. System solutions provide organization with operate environments specific to operational and informational needs. High availability transaction processing, scalable data warehouse systems, enterprise management system product, security system product, software as a service, business process outsourced, industry solutions, implementation of an industry architecture, reusable package of products and services specific to an industry, made up of system solution and or products and services, augment with industry-specific components, example, physical database schema, and industry-specific point of service device, industry-specific, ready to be tailored to the requirements of an individual enterprise. Organization-specific solutions, implementation of the enterprise architecture that provide required business function, unit contain to meet foreign specific needs of people and the process of organization, support specific surface level agreement and the key operating parameters and the quality metrics. Key link between architecture development and operation personnel for agreements. Primary purpose of connecting architecture continuum to solution continuum is to build organization solution from industry solutions, system solutions, product and services. Let's explain it once again in a fresh manner. The enterprise continuum contains information organized from very generic to highly organization specific. This includes foundation level, common level, industry level, and finally specific to an organization. The enterprise continuum typically lives in a library called the architecture repository. It's a collection of architectural artifacts and materials. The enterprise continuum is typically split between what we call the architecture continuum and the solution continuum, and both of these two areas have generic and highly specific artifacts. The enterprise continuum allows us to easily reference specific or generic when describing the what and why and the how of a design. It makes communication with both internal and external stakeholders, enterprise, suppliers, and vendors much easier and allows for fast decision making. It also aids in effective use of vanilla product, which we call commercial off-the-shelf product. The enterprise continuum consists of assets, artifacts, and solution products during the application of the ADM. This includes deliverables of previous architecture work done by both you and other enterprise architects. The continuum provides a valuable library of reusable material for you to use, adapt, and tailor to your current vision and design. This way, you are always improved. The enterprise continuum has many parts. The first, classify asset for the overall enterprise architecture. It influences but might not be directly used during the ADM development phase. This type of document includes standard policies, achieve structure, and capabilities. The second part is called the architecture continuum, and it is one side of our pyramid. It defines rules, representation, and the relationship using architecture building blocks or ABBs. These can help reduce complexity when multiple standards are being referenced by improving feasibility on overlapping, unnecessary, or even redundant processes. Other side of my pyramid is the solution continuum. This defines how to implement the asset in the architecture continuum using this very modular block called solutions building blocks or SBBS. Looking at the solution types in detail, we start with the foundation level. In the architecture continuum, this is very generic component interrelationship principle or guideline. And in the solution continuum, this is typically again generic, but it is a concept tool, product, service, or solutions. We then get more specific and our solution become a common level. In the common level in the architecture continuum, we use this type of solutions to help guide selection and integration of a specific service from our foundation architecture. On the solution continuum, these are typically a set of reusable products and services that provide organizations with vanilla operating environments. The next level is industry. In the architecture continuum, industry level solutions help guide the integration of specific industry solutions for a very specific customer problem. On the solutions continuum, this is typically ready to be tailored, ready for organizational use, and already includes some of the components, products, services, and systems that are made just for that industry. And finally, the highest level of specification is the organization solution type. On the architecture continuum, this is a very detailed document that describes and guides the final deployment of component for a specific organization. On the solution continuum, this usually contains components that have been very tailored and are very unique to an organization. It is people and culture and it is processes. The relationship between the architecture and solution continuum is stated. The enterprise continuum helps improve productivity through leverage. The architecture continuum specifically offers a consistent way to understand the component, whereas the solution continuum offers a consistent way to understand the product, system, service, and solutions. Together, the architecture and solution continuum both provide this productivity and leverage. When we talk about the ADM describes the process of developing enterprise-specific architecture by iterating through specific phases. There is a give and take relationship here. On the take side, during an ADM phase, the architect can reference generic architectures and solutions from the enterprise continuum to help guide and design. On the give side, as the final product design and deliverables get defined, the ADM contributes to the enterprise continuum by improving the assets and evolving them to become more specific. Architecture repository. An architecture contains storage capability that manages all of the architecture information of an enterprise, include data and process model, other enterprise information. Allows an enterprise to distinguish between different types of architecture assets that exist at different levels of abstraction in the organization. One part of the wired enterprise repository, which provides the capability to link architecture assets to components of other repositories, design and deployment, and service management. There are 8 classes of architecture information held within the architecture repository: architecture metamodel, architecture capability, architecture landscape, standards library, reference library, governance repository, architecture requirements repository, solution landscape. The architecture Metamodel describes the organizational tailored application of an architecture framework, including a method for architecture development and the container framework and the Metamodel for architecture contain. The architecture landscape shows an architectural view of the building blocks that comprise the enterprise architectures at a particular point in time. The architecture capability defines the structures, roles, responsibilities, skills, and the processes that support governance of the architecture repository. The reference library provides guidelines, templates, patterns, other forms of reference material can be leveraged in order to accelerate the creation of new architecture for the enterprise. Can use the architecture continuum as method for classification. The standard library captures the standard with which new architecture must comply. May include industry standard selected products and services from suppliers or shared services already deployed within the organization. Three classes of standard: legal and regulatory, application, industry standards, and organizational standards. The governance repository provide a record of governance activity across the enterprise, decision log, compliance assessments, capability assessments, calendar, project portfolio, performance measurement, architecture requirements repository, provide a view of all authorized architecture requirements which have been agreed with the architecture board, solution landscape, present an architecture representation of the SBBS supporting the architecture landscape which have been planned or deployed by the enterprise. Let's explain it once again in a fresh manner. The architecture repository consists of 8 classes of information. The first is the architecture meta model. This describes a tailored application of an architecture framework, including a meta model for architecture content. The second is the architecture capability. This describes parameters, structures, and processes that supporting the governance of the overall repository. Next, the architecture landscape describes a list of building blocks that are currently in use within the enterprise at any point in time. The standard library describes standards which new architecture must comply with. The reference library is reusable material such as guidelines, templates, and patterns. The governance repository is a record of all governance activity that's kept in one place for easy audit, decision making, and transparency. The architecture requirements repository is a library of all authorized requirements which we have agreed to with the architecture board. And finally, the solution landscape is a list of all the current and proposed solutions building blocks that are currently in use as the organization. The three levels of architecture landscape include strategic architecture and segment architecture and capability architecture. Strategic architecture is all about the long-term view of the entire enterprise and where it's going to go. This helps with very strategic decision making. It organizes operational and change activity for us. Segment architecture has more detailed models for areas with an enterprise and help with sub-project and program management. Capability architecture is an overview of current capability versus where we want to go with our target capability. It helps understand how sub-project and the work packages inside them will help us achieve the target capability. The standard library is the architecture landscape that produces best practice standards. The standards are stored in the standard library. During project design work, you have to comply with all of the standards in that base. Standards should be written in a clear and ambiguous manner so compliance can be binary. You either are compliant or you are not compliant. Having a standardized set of tools is important. It helps promote the reuse and either communications between you and stakeholders, enables the sharing of architecture and solution information. It makes architecture either to maintain, and it allows you to use models when responding to stakeholder requests. architecture principles. When we are talking about guidelines and principles, let's first understand what architecture principles are. These are rules and guidelines developed during the preliminary phase, like a mission statement principles. Once stated are really amended, there are enterprise principles and architecture principles. Enterprise principles harmonize decision making and dictates how the organizational mission will be fulfilled. Architecture principles, on the other hand, govern process affecting development, maintenance, and the use of the enterprise architecture. Here an example of an architecture principle. There are a couple different sections, include name, statement, rationale, and implications. The name should be written in an easy to remember, simple, clear, and concise manner. We typically avoid reference specific platforms, software, and technologies. For example, we might name a principal self-serve. Then their statement. That statement is supposed to succinctly and ambiguously communicate the principle. For example, for self-serve, customers should be able to serve themselves. A rationale is included to help business benefit of adhere to the principle become known. In my example, if we had self-serve, it would improve customer experience and reduce our overhead. The implication sections talk about what is in it for in terms of resources, costs, and activities for those carrying out the principle. For example, if you carry out the principle of self-serve, it will improve the ease of use, it will minimize corporate training required for our stores, and it allows us to offer cross-selling opportunities during checkout. When it's stated like this, self-serve becomes very easy to understand and the value is very clear. This is what makes a good architecture principle. Stakeholder management. Stakeholder is an individual, team, organization, or class thereof having an interest in a system. Stakeholder management is an important discipline that successful architecture practitioners can use to win support from others. It helps them ensure that their product succeed where others fail. The benefit of successful stakeholder management are that knowing who the most powerful stakeholders are, the most powerful stakeholders can be identified early and their input can then be used to shape the architecture. This ensures their support and improve the quality of the models produced. Makes things easier for when more resources, thus making the architecture engagement more likely to succeed. Support from the more powerful stakeholders will help the engagement when more resources, thus making the architecture engagement more likely to succeed. The architecture team can more effectively anticipate likely reaction to the architecture models and reports. The architecture team can more effectively anticipate likely reaction to the architecture models and reports and can build into the plan the actions that will be needed to capitalize on positive reactions while avoiding or addressing any negative reaction. The architecture team can identify problems and conflicts early in order to avoid them. The architecture team can identify conflict or competing objectives among stakeholders early and develop a strategy to resolve the issues arising from them. A gap analysis is a technique that validates an architecture being developed. Gaps are shortfalls between some baseline and a target that is omitted, accidentally left out, or perhaps not yet defined. There are different sources for gap. Business domain gap can exist within people, process, tools, information, measurement, financial system, and facilities. Data domain gap can be all about the relationship, the creation or consumption of data, the location of that data, the level of quality or currency, or even type of data. Application gap could exist with applications that might be impacted, eliminated, or created due to your architecture work. Technologies impacted is similar in that we look for things that are impacted, eliminated, or created as a result of your architecture work. To perform a gap analysis, we first start with making a chart to show the architecture building blocks that exist in the current baseline shown on the left versus the target baseline shown across the top. If an architecture building blocks exist in both the baseline and the target, we consider it included and mark it as so. If an architecture building blocks exist only in the target architecture but not in the baseline architecture, it's marked as new. If an architecture building blocks exist only in the baseline but not the target, we should review it to make sure it is not something that we have forgotten about or missed. If the architecture building block is not missing and intentional, we mark it as intentionally eliminated. Migration planning technique. This chapter contains a number of techniques used to support migration planning in phases E and F. The technique of creating an implementation factor catalog can be used to document factors impacting the architecture implementation and migration plan. The catalog should include a list of the factors to be considered, their descriptions, and the dedications that indicate the actions or constraints that have to be taken in consideration when formulating the plan. Implementation factor catalog. Factors typically include risks, issues, estimation, dependency, actions, impact. An example where maybe you have decided that one of your things you need to do is shut down the message center, basically having 700 employers reply to message and having it basically an email operation, and this is going to save you a lot of money. But one of your factors is going to be the fact that need for personal training, reassignment, and email has mega personal saving and should be given priority. And also one of the factors, of course, is that cost savings. You are basically going to save a lot of money by implementing this change. You can come up with all of the different things that are part of your migration plan and what are the factors that you need to keep in mind when making certain decisions. Next up is called consolidated gaps, solutions, and dependencies. Now we saw the gap were identified during the PDAT phases when you are doing the baseline and target architectures and identifying the gaps and so this matrix. This list is basically a way for you to identify what's going to be included in different work package, and the work package are the ones that are identified during the migration plan. Architecture definition increment table. Architecture definition increment table allows the architect to plan a series of transition architecture, lists the projects, and then assign their incremental deliverables across the transition architecture. Transition architecture state evolution table. There is also something called a state evolution table where it is basically the state of various architectures at various level, makes it easy for someone at glance to see that in 6 months and 9 months after the implementation of the first rule out, this is what feature and function we are going to have, what surface will be available, and which one are still in transition. You can even use like a green, yellow, red color coding so that people will know the states of various surfaces after each transition architecture. business value assessment technique. And finally, there is a technique called the business value assessment technique. And basically, when you are in the implementation, you have your product first to find out are they either on track or they are at risk on being behind or they are actually behind, and you have certain business values associated with each project. And so it is not enough just to know that one particular team is behind, but what is the impact that team played on your overall business value. Another way to look at this is various diagrams where you have circles, the size of circles, the circle's size corresponds to the project expander or the value obtained, while colors such as green, orange, and red signify the project stats. Consequently, this serves as an artifact that you can use to identify how things are going. Interoperability requirement describe the level to which information and services are shared. They are categorized as operational information or technical. The architect ensures that there are no interoperability conflicts, especially with respect to the reuse of solution building blocks or commercial of the shell product. Interoperability requirements come into play in different phases of the ADM. Typically, so these are phases A through F. In the architecture vision phase, interoperability is implemented when we are talking about the nature and security consideration for information and service exchanges. In the business architecture phase, we discuss interoperability when we are discussing about the information and the service exchange as they are defined in the business talk. In information system architecture, interoperability is discussed in two areas. In the data domain, we are talking about the content of the information and the data exchange model, as well as the application domain when we talk about the way that applications share their information and services. In the technology architecture phase, interoperability is implemented when the technical mechanisms to prevent the information and the service exchanges are discussed. In the opportunity and solutions phase, we discuss interoperability when we discuss the commercial of the shelf package vendor and during their selection process. And finally, in migration planning, we discuss interoperability when we are implementing logic. Transformation readiness assessments helps us determine what factor will impact a business transformation and if we are ready to have this transformation occur. It is best completed in a workshop session where there are lots of participants stand around that can reuse, reject, augment, or replace a list of factors. This type of discussion usually leads to a lot of opening thought about planning. There are different readiness factors listed on screen. An example of some might be vision, urgency, filtering, the current amount of funding, do we have the right sponsorship, the governance model, do we have IT capacity, or do we have HR capacity to be able to handle the work. When we use a chart like this, not only can we discuss the stats of a readiness factor and the areas of concern, but we can also brainstorm some actions so that we can become ready. This prevents this type of workshop from becoming a compliance session and being a more productive session. Risk management is an important aspect of your work. It focuses on identifying, classifying, and mitigating risks. Readiness assessment and capability maturity model help surface and identify these risks through the rich discussion you have with the people involved. There are two types of risk we document. The first is an initial risk, which is the risk before taking any action. And the second is residual risk, which is the risk after taking some mitigating action. For each identified risk, we discussed the effect and frequency to arrive at final corporate impact risk. Typically, we will use a scale like extreme, high, medium, or low. And there is a symbol of this on your screen. The effect is the list on the left, which goes from negligible, marginal, critical to catastrophic, and across the top is frequency, which starts with unlikely, seldom, occasional, likely, and frequent. That chart helps us understand our corporate impact risk by inputting the effect and frequency and outputting the letter that correspond to corporate impact. We then document our mitigation actions and recalculate the impacts to see if our plan has made an agreeable difference. The risks have to be approved by the government framework before mitigation action can be implemented and work begins. Using a before and after chart can really help in making your thinking feasible. Here is how you do it. Take a page and split it in half. On the left side, talk about your initial risk. Write down the current risk that you have, the effect, frequency, and the impact of those risks. And on the second half on the page, write down any mitigation action you can think of. You will also document the effect, frequency, and impact of the residual risk or what's left if your mitigation action and the plan are taken. By using this kind of chart, it makes it very easy to communicate with stakeholders and executive exactly how you plan to perform your risk management. Architecture alternative and trade-off. Architecture alternative. It is a technique identify alternative target architectures and build understand of different possibilities and identify trade-off between the alternative. Presenting different alternative and trade-off to stakeholders. It's help architect to extract hidden agendas, principles, and requirements that could impact the final target architecture. And more than one target architecture can fulfill the same architecture vision pretty straightforward. Making a decision among this alternative requires a precise assessment of requirements, prioritization, and an estimation of the cost and risk associated with each option. And so when you are making the decision which architecture to use, it's really just a matter of trade-off. And here a list from spec of the some example of criteria that you might use when you are making a trade-off. Flexible alternative. Some solutions are give you more flexibility. Time and cost of realizing the alternative, including any transitions and plateaus. Some solutions are faster and cheaper versus longer and more expensive. Some solutions might be easy to implement but take a longer time before they really add value to your business. Time period over which estimated benefits of the alternative will be achieved. Adherence to architecture styles or guidelines and whether or not a solution directly adhere to your principles or whether you are willing to make some compromise in order to trade off with something else. Solution delivery method example reuse developed by minimal impact on business capabilities during implementation of the alternative. For instance, if you opt to shut down your online store for a few days to ensure a smooth migration, it is a substantial trade-off. On the other hand, if you choose to continue business operation during the transition, minimize risks associated with the alternative and any mitigating action needed. When developing architecture, there can be multiple target architectures that are conformed to the architecture vision, the architecture principles, and the given requirements. And valid target architectures can have advantages and disadvantages, and sometimes there is not even a single target architecture that meets all stakeholder requirements. Your job as an enterprise architect is to identify alternative target architectures, build an understand of the different possibilities, and identify trade-off between the alternative and competing forces. But presenting the architecture alternative to the stakeholder, you can extract hidden agendas of the stakeholders or identify new architecture principles or requirements. The token standard provides techniques to investigate different alternatives and to discuss this with the stakeholders. First, use the vision principles, requirements, and other information to select it of criteria fitting for different alternatives. Second, you define alternative based on the criteria and build an understanding of each alternative. Finally, you select one of the alternatives or combine features from multiple alternatives to create the proposed target architecture. Architecture governance is all about how architecture are controlled and managed. It includes systems that enable controls over compliance with standard management support process and practice to ensure good, strong accountability. It typically exists within a hierarchy and interacts with other things like corporate governance, technology governance, and IT governance, which all could coexist at an enterprise. It also may exist at different levels of geography, such as global, regional, and local. Why do we need architecture governance? Well, there are quite a few benefits. The first is that we can better control risk management. It also maximizes the reuse of exist components. You get a greater stakeholder value and it ends up becoming part of your organization's secret sauce or what makes you special. It improves proactive control and management. And also, good governance leads to better monitor, measurement, evaluation, and feedback. This adds control capability, increase transparency of accountability, and informed delegation of authority. Overall, good, strong governance means improved decision making and feasibility between the requirements. When we talk about governance from a conceptual structure, it is a contained agnostic approach that focuses on the key process, include policy management, compliance, dispensation, monitoring and reporting, and business control and environmental management. The process ensure integrity and effectiveness of the organization architecture. From an organizational view, organizations need to be well organized in order to support governance. The key areas of develop, implement, and deploy is the responsibility of typically one or more groups in the organization. For example, the develop area may be controlled by the architecture board, which in turn has chief architect, enterprise architect, and domains architect supporting them. The implement key area might be assisted by the project manager office. In turn, the project manager office has the help and support of senior project managers, subject matter experts, and project coordinators. The deploy key area might be assisted by the service management team. The service management team has multiple functions and groups of problem managers, incident managers, and event management system and tools to assist them. Each of these areas interacts with the enterprise continuum. So you wish to establish an architecture capability. Great. Like any business, this requires functional and operational guidelines. Functional guidelines are strategic guidelines and frameworks, and operational ones are rules, responsibility, skills, and process. The architecture capability framework has multiple components. The first is an architecture board, which has to have guidelines for how that board should operate. There is architecture compliance, which has to have guidelines for how the compliance will be achieved. When architecture contracts are rated, we have to have guidelines for how they will be rated, documented, and the manner in which they will be negotiated. Architecture governance has guidelines for who and how we are going to provide oversight for our project. Architecture maturity models include guidelines for where our growth milestone and stage will be. And finally, the architecture skills framework has to have guidelines for what skills and knowledge staff need to process. Running an enterprise practice like a business requires strong capability and very knowledgeable staff. Typically, the staff have to be in financial management, service management, resource management, quality management, configuration management, performance management, risk management, communications and stakeholder management, suppliers management, and environment management. This entire orchestra of people will assist you in making sure that your enterprise practice not only runs like business but a strong one. An architecture capability should be an ongoing effort, not a one-off project or a phase of a project. It requires the compilation of design activities in each of our BDAT architecture domain. For our business architecture, we have to have activities related to governance, process design, organizational structure design, and the products for the practice. In data architecture, we have to define the structure of the enterprise continuum and the architecture repository that are going to be used by the practice. The application architecture will specify the functionality required to enable the practice. And finally, the technology architecture will specify the specific infrastructure and deployment requirements that are necessary to build our architecture capability. The architecture board helps oversee the implementation of governance strategy. It is representative of all the key stakeholders in the architecture. The goals and responsibilities of the architecture board include a basis for decision making on architectures, improving the consistency between sub-architectures, encouraging and setting targets for the reuse of components in the library, enforcing compliance, improving the maturity level of the organization, providing an escalation point for decision making, monitoring and controlling architecture contracts, and finally ensuring that architecture is treated as a discipline and not an afterthought. Architecture contracts themselves outline deliverables, quality, and fitness for purpose. The architecture board is involved in continuous monitoring of the integrity, change management, audit, and decision making for this contract. Contracts should always be aligned with the principles, standards, and requirements of the overall organization and enterprise. Let's explain it once again in a fresh manner. So if we look at the contracts that typically happen, it is usually going to contain a system of continuous monitoring to check integrity, change decision making, and audit of all architecture related activities within the organization. Adherence to the principles, standards, and requirements of the existing or developed architecture. Identification of risks in all aspects of the development and implementation of the architecture, covering the internal development, hygienists, accepted standards, policies, technologies, and products, as well as the operational aspects of the architecture, such that the organization can continue its business within a resilient environment. a set of process and practice that ensure accountability, responsibility, and discipline with regard to the development and usage of all architecture artifacts. And finally, a formal understanding of the governance organization responsible for the contract, their level of authority and scope of the architecture under the governance of this body. Architecture compliance. There is different level of architecture compliance that we can discuss. The first is irrelevant. The description of this is that the implementation has no corresponding specification to adhere to. The second is consistent. In this case, the implementation overlaps with some of the specification. Compliant is when the implementation is smaller than the full specification and meets the specification. Conformant is when the implementation is much bigger than the actual specification, but it still meets the requirements of the specification. Fully conformant is when the implementation matches the full specification, no more, no less. And finally, what you don't want to hear, non-conformant. Non-conformant is when any of the above situations exist, but the implementation goes against the specification in any manner or size. The compliance review. The compliance review process is a 12-step process to catch early errors, ensure application of best practice, identify, communicate gaps and stats, and help everyone work better as a team. The steps are laid out on the slide. It includes starting with an architecture request, then identifying the organization that's going to support it, identifying a lead architect, determine a scope, tailoring our checklist, scheduling an architecture review meeting, interviewing the project principals, analyzing those completed checklists, prepare a report, presenting our findings, and finally accepting review and sign off, and creating a summary report. Let's talk about a few key definitions. The first is the concept of a system. The definition of a system is a combination of interacting elements organized to achieve one or more state purposes. An example of this would be a communications network. A system has one or more stakeholders. The stakeholders are individual teams or organizations that play key roles in and might have concerns about the overall system. An example of a stakeholder could be HR, quality control, the IT team, or executive. Concerns or issues requiring clarification. This could include a problem to solve, a decision to make, a risk to avoid, or an opportunity to exploit, or an action to take. Concerns are held by stakeholders. An example would be, I would like the network fast enough to send lots of video. Architecture view are a visual representation of a system that shows stakeholders that their concerns are being met. For example, here is a picture of a network diagram. See how we have designed it. Doesn't it look like it could transfer a lot of fast video? Architecture viewpoint, on the other hand, are generic templates for an architecture view. Architecture viewpoints help frame concerns. For example, an architecture viewpoint could be a visual template of network objectives describing a modeling technique, a list of concerns, and the stakeholders involved. The architecture view creation process is as follows. We start out by first reference the architecture repository for anything that we can use. Then we select key stakeholders, interview, and document their concerns. We select the architecture viewpoint that best meets those needs and use it as a template. Using the viewpoint as a template, we then generate a view of the system. We have to make sure that the view addresses all the concerns of the stakeholders and document any trade-off in the design approach. Architecture patterns are like recipes. They identify different combinations of building blocks that have been successfully used in the past. They reference how to use combination of building blocks, the when, the why, and the impact and the trade-offs of doing so. As the underlying building blocks evolve, so does the overall quality of solution and the pattern that they can provide. Let's talk about foundation architecture. Foundation architecture reflects general requirements and building blocks. It defines technology standards for implementing those building blocks and provides directions for products and services. It reflects the function of a complete robust computing environment. It also provides open system standards, directions, and recommendations. It reflects the overall direction and strategies that you can implement. There are two goals for boundaryless information flow. The first goal is integrated information so that different and potentially conflicting information and data is minimized across all the systems. The second goal is integrated access. This is so that staff can access information they need through one convenient interface. Next step, I know we went through a lot of different material in our exam prep course. I encourage you, since each of the sections of this course are based on the learning outcomes you are supposed to be responsible for before you take your exam. To go back to each of the sections and incorporate your own examples into the techniques, definition, and items you have learned. Review any concepts you weren't confident in prior to taking the official exam. Thank you so very much for taking this course, and I am honored to be part of your journey.